Good morning after a short break. Today I like to give you some information concerning mineralogical technologies possible for use on the Mars. We will start from the rocks. The classical, typical primary rock on the Mars. There are basalts, various kinds of basalts. I have no data. I have no photos of basalts of Mars. But most probably there are similar basalts as in the Earth, like on the Moon. This is photo done by NASA block of basalt with olivines, silicates of magnesium and iron, and these red points, there are places of chemical analysis, and we know chemical composition of minerals building basalts on Mars. So it's most probably that these basalts are similar to basalts we have on the Earth. There are photos of Polish basalts, basaltoids. They are built of pyroxenes and olivines or minerals. And this black background, there is volcanic glass. Most probably basalts present on the Mars are similar. There are various kinds, there are small differences, but generally most probably similar. What we may obtain, what we may produce using basalts. One of product is mineral wool, a thermal isolator, important on the Mars because it's much cooler than on the Earth. The basalt for production of rocky wool is basalt wool is melted at 1400 degrees, and later artificial magma is cooling and there are produced fibers of material known as rocky wool. Buildings on the Earth, on the Mars, have to be thermally isolated, so this material probably will be very useful. We are able to produce oxygen using rocks because most of minerals present in basalts, minerals belonging to the plagioclases like anorthite, is aluminum silicate, contain about 45% of oxygen. This means that 1 ton of olivines contains, for example, of olivines contains 250 kilograms of oxygen. This is silicate of magnesium and iron. And anorthite much more, because 1 ton of anorthite contain about 450 kilograms of oxygen. So melting and using special technologies we are able to obtain oxygen from rocks. Oxygen important for us for breathing. Photos done by NASA, there is one example and published, document presence of this kind of probably sedimentary rocks, showing typical mud crack structures as a result of drying of rocks where are minerals containing the water. These fractures, these spaces are most probably because of the drying. It's for documentation, but future documentation. This kind of rocks, probably much softer than basalt, is possible to use as a material for construction of architectonical objects on the surface of Mars. It's possible to cut it and to prepare blocks or forms similar in the shape to bricks. It's using the electric diamond cutters, so we are produce material for construction of so-called houses, blocks. Last expedition discovered presence of the gypsum on the surface. This gypsum is present in form of veins of various thickness, but gypsum is mineral containing water and is used in the earth as material for production of mortar, of plates, gypsum plates, etc., and used in building technologies. So if we have gypsum, we are able to produce mortars, and for example, using CO2 from atmosphere and calcium, we may obtain calcite, which is used as material for production of mortars. So hydrated mineral like gypsum is possible to use for production of the water, because in each particles of gypsum there are 2 particles of water. So heating gypsum, we are able to obtain from gypsum water, and from water we may obtain hydrogen. CO2 present in the atmosphere of Mars will be used for plants, because plants for production of tissue need CO2 for construction of bodies, let's say. In the Earth, in the Mars, we have, as is documented, about 95% in atmosphere. This is called carbon dioxide. So we made this carbon dioxide used for production of carbon and oxygen using energy of lightnings, small lightnings. We did experiments in Poland, and we may obtain about 17% of pure oxygen using this technology. This photo of experiments where in the container we have CO2 and the lightnings which look like one lightning, but there are many lightnings during the second, are destroying the bindings between C and O2, and this process is leading to separation of C and O2. Together with oxygen is produced argon and traces of N. So if we obtain water from, for example, from gypsum, we are able to do electrolysis of water and produce hydrogen and oxygen from water. Hydrogen is especially important as a fuel for rockets. So for local transportation, it's important. Oxygen important for life of people. One ton of gypsum, which contain 21% of water, contain 210 kilograms of water. So during the heating, where we heat, the water is evaporated from gypsum and later is condensated to water by cooling. And using this technology, we are able to obtain water from gypsum, from mineral. Pictures of surface of the Mars as well as materials present in internet show that some rocks, sedimentary, so-called sedimentary rocks, most probably contain clay minerals on the Mars. And this is important because of possibility of preparation of artificial soil. Our students in AGH did a mixture of various minerals similar to the, let's say, to the earth, to the soil present on the Mars. And they did growing, they prepared as a base for growing of plants, and they use hydrocultivation, and on this, let's say, artificial soil, let's say Martian soil, they obtain growing plants. So it's very interesting. So this means that it's chance to use local soil of the Mars, and if there will be water, and it's chance to produce various kinds of plants important for life on the Mars. Separate problem interesting, this is presence of ore minerals in the rocks of Mars. Documentation in internet presented by NASA show presence of this kind of elements and other, and some are in quite big quantity. For example, iron present in the basalt after oxidation make reddish iron minerals which make surface of Mars red, probably because of this of iron minerals, oxides, we observe this planet as a red. And on the surface, if on the surface of Mars there are iron oxides, this means that in the past, of course, the atmosphere contained oxygen, and there was kind of weathering, there was type of oxidation of iron minerals leading to formation of oxides, red oxides. This titanium, zinc, and aluminium, silica, etc. So it's very possible that on the Mars there are deposits of iron and other ore minerals, deposits, so special concentrations, because documentation done up to now show that these minerals are present in rocks in dispersed form as admixture of iron and other minerals or minerals. But most probably there are places where these minerals of these elements are present as concentration in form of deposits. So we are able to discover these deposits and use material for various products. Separate problem on the Mars, there is production of energy necessary for life, for functioning of various machines, etc. Artificial light, so we may use wind energy, electric energy, most probably thermal energy, because under the Earth under the surface of Mars, probably temperature is much higher, so it's kind of heating. And of course, nuclear power plants we may use for production of energy necessary for various products for life, etc. So knowing all this, what we know up to now about the Mars and mineralogy and rocks, etc., atmosphere, is necessary to say that life on Mars is possible. Of course, it's much more complicated than on our Earth, but using various technologies, we may obtain water, we may obtain oxygen, we may obtain thermal isolating materials, we are able to obtain ores and hydrogen and other products. Of course, it's much more complicated than on our Earth, because we have to produce, for example, oxygen. In the Earth, we have oxygen in the atmosphere, but using various technologies, we may obtain a lot of various products important for life, for agriculture, for plants, and for life on the Mars. So thank you very much for listening, and see you next time again.